All right, so where does this go next? Well, believe it or not, you at this point actually have. So we have a pretty good idea of how to evaluate limits. I know it's a fairly new topic for you, but we actually have pretty much what we need moving forward. We learned, just kind of to recap, we learned how to do it from a graph. That was presented to us in topic 1.3. We know how to do it from a table. That was presented to us in topic 1.4. And now, through our algebraic properties from the previous topic and what we learned today, we also now know how to do them analytically using our algebraic properties. So remember the idea of what we were trying to come up with here. Limits are going to allow us to define several things in this course. Where it's going to head in the very short term here, limits will allow us to formally define the idea of continuity of a function. And I would encourage you to start thinking about that, because right now your Algebra 2 pre-calculus definition of continuity, you've probably been told that that means you can draw a function without picking up your pencil. Well, you're going to graduate from that definition into a more formal one, and I would encourage you to start thinking about how limits might play a role in defining the continuity of a function. The other big thing, at least here in the short term, that limits are going to allow us to do is this whole idea we started with back when we started topic 1.1, discussing the idea of instantaneous rate of change. Limits are going to allow us to find this instantaneous rate of change because what we're going to be looking at is we're going to be looking at the limit as delta x approaches 0 of change in y over change in x. And this is something that you've been kind of finding. If you look all throughout this lesson, we've been looking at the limits of rational functions where we kind of get this idea that the numerator's approaching 0 and the denominator's approaching 0. So right now we're just building that skill to evaluate limits, but here in the very near future we're going to use this idea of change in y over change in x to formally establish this idea of instantaneous rate of change, which we'll later go on to define as the derivative.